Previously, in 8051 microcontroller video series, we have gone through block diagram, RAM structure, and PSW register of 8051 microcontroller. Today, in this video, we'll be learning about 8051 microcontroller instruction sets. This video series is presented by RLC-EEE. Without wasting our time, let's begin the topic. Instruction sets. 8051 microcontroller has rich instruction set that allows arithmetic and logical computations. In order to perform arithmetic and logic operations, the CPU needs the data. That data may be internal or external memory or an immediate data. Depending upon the operation of moving the data and processing of the data, the instructions are classified as first, the data transfer instruction, that is moving of the data between internal memory or external memory or to the CPU. The next, arithmetical instructions. Arithmetical instructions are like addition, subtraction, multiplication, division, like that. Next is the logical instruction, performing AND operation, OR operation, XOR operations, NOT operations. This all comes under logical instruction sets. Next, bit processing, that is Boolean variable manipulation, taking an individual bits, making an OR operation, AND operation, clearing of the bit, setting of the bit. These are all comes under bit processing instructions. The next is program branch. Like depending upon the condition, the program may have to step onto some other location and process the data and needs to come back. These will be taken care in the program branch instruction set. Now we will study in detail with data transfer instruction. Microcontroller or microprocessor spends maximum time in data movement operations. Therefore, maximum instruction sets are provided for the data transfer rather than any other type of operation. Each and every, like the data transfer instruction has an opcode of move, and we need to specify where we need to send the data, that is the destination, and from where the data has to be sent, that is the source. Here, every instruction consists of an opcode and also it consists of an operand. Opcode is the one which will be designed at the time of manufacturing. It is an hardware design. We cannot change it. We cannot change it. If we want to change the opcode, we need to change the hardware design itself. Whereas operand is like a variable where the data will be stored, Here we can see the move is an opcode which indicates the data transfer instruction is being executed. Then this destination and the source, we are telling from source copy the data to the destination. From source copy the data to the destination. That is what this move destination comma source instruction states. This destination and the source can be of different types. We'll see that. First, the destination. The destination can be a register, it can be a direct memory location, or it can be a pointer. It can be a pointer, whereas the source can be a direct data or the immediate value. Then rest of all will follow the same. That is, it can be a register, it can be memory, or it can be a pointer. It can be a pointer. Now we can see over here, the source can be an immediate value, or the destination source can be a register, or it can be the memory location, or we can use a pointer. So there are different ways where we can use this move instruction. That is, we can use the immediate value, we can use the memory location, we can use register or the pointer. So on these basis, the instruction sets, okay, we call it as an accessing modes. We have different addressing modes. These addressing modes are First is immediate addressing mode. First one is the immediate addressing mode. That means directly we are transferring the data to the destination. The source will be the data and the data will be transferred directly to the destination. That is immediate addressing mode. Next is the register addressing mode. In register addressing mode, register names are used. Register names are used. Then in direct addressing mode, direct memory locations are being used. Direct memory locations are used. Next, in register indirect addressing mode, we'll be using the register as a pointer. We'll be using the register as an pointer. Those type of addressing modes we call it as register indirect addressing mode. Then finally we have indexed addressing mode, which is used to read the code memory, We'll go through the explanation of each and everything in detail as of now. First one is immediate addressing mode. First one is the immediate addressing mode. In immediate addressing mode, we said we are passing the data directly. Then the source will be of data. For example, we can take move a comma hash 0AH. Here move indicates it's an opcode, then a is the destination. This part a is the destination, that means a means accumulator. The next hash 0AH, this is the data. Hash 0AH is the data. That means we are passing 0A to the accumulator directly. This type of addressing modes we call it as immediate addressing modes. The same can be represented as move r1 comma hash 0FFH. That means here the destination I have changed. It is not that only A can be there, it can be registers also from R0 to R7. Here the example we have taken R1. Then I am passing the data directly to the register R1. We have it's not that we can pass only 8-bit of data. We can pass 16-bit of data also directly to a register which is of DPTR. We know DPTR is of DPH and DPL, which is a 16-bit register. So here we can pass 16-bit data directly. We can pass 16-bit data directly or 2 byte of data. Now, if you observe here, in the first instruction, we have used hash 0AH. This H indicates it's an hexadecimal number. The capital H indicates it's an hexadecimal number. And there is one more notation which we can use is of small h. We can use small h also, or else we can use before number, we can write 0x. 0 with small x indicates this is an hexadecimal number. It is not that we should pass only the hexadecimal number. We can also pass decimal values. To indicate the value passed is a decimal number, we'll be using D. We can observe here we have D in this part. So it's not that only capital D, we can use small d also. And if we are not mentioning anything, whether it is not mentioned as h or small h or 0x or d or small d or lowercase d, that number will be considered as decimal number. Same as this, we have one more note, we can pass the binary data also with indicating as B, with an indication B. So here we can see this is B, this is B. Okay. Next, we'll move on with register addressing modes. Now in register addressing mode, the name itself indicates we'll be using the registers. In immediate addressing mode, we can see immediately we are passing the data, that is source will be the data. Here register addressing modes means the destination or the source can be a register. The destination source will be a register. We'll see with few examples. Move a comma R0. Move a comma R0. That means R0 value will be sent to accumulator. Whatever the data present in the R0 will be sent to the accumulator. Assume R0 is having a value of 20H. After executing move a comma R0, accumulator will also have the value of 20H, and we can observe this value will not be erased. That is the data inside R0 register will remains as it is. It is not altered. Only a copy of this data is transferred to the destination. A copy of the data is transferred to the destination. That is move a comma R0. Same we can write it like move R1 comma A. That means here whatever there in the accumulator, those values are being transferred to register R1. The data present in the accumulator is transferred to the register R1. We know we have registers from R0 to R7. So we can consider this R0 or R1 instead of writing move a comma R0, move a comma R1, move a comma R2, something like that. We can indicate it as move a comma Rn or move Rn comma A. This one, move a comma Rn or move Rn comma A. Now, in the right side of this screen, we can observe two instructions which are written in red. That is move R0 comma R5. This is indicated in red because this instruction is an invalid instruction. We cannot transfer data between two register sets. Like we cannot transfer R0 data to R5 data directly. This is not possible. Not possible. So it's been indicated here Rn comma Rn means n can be from this n can be from 0 to 7. Same as we can observe we have still two more instructions which have been indicated as invalid. That is move dptr comma A. Move dptr comma A, because dptr is a 16-bit register. dptr is a 16-bit register, but accumulator is an 8-bit register. If we try to pass 8-bit data to the 16-bit data, like we are going to get a short of 8 bits. Because of this instruction is an invalid instruction. Same as it is move dptr comma Rn is also an invalid instruction because Rn, that is R0 to R7, it is also of 8-bit data. So dptr 16-bit, where we cannot pass the 8-bit data to the 16-bit data location. This is with addressing modes. Mainly we need to remember this move Rn comma Rn, that is move R0 comma R5, R0 comma R1. This is not possible in the 8051 microcontroller register addressing mode. Next we'll see with direct addressing mode. In direct addressing mode, the name itself indicates like direct address. In the name we can see it is direct address. We are using address location directly. Address location directly. We know 8051 microcontroller is an 128 byte, consists of 128 bytes of RAM, which are from 00H to 7FH. The memory locations are addressed from 00H to 7FH. When we are using these addresses, instead of naming it as R0, R1, R2, if we use directly the address, then we call it as direct addressing mode. So here move a comma direct. This direct means this is a memory location. This is a memory location. So here move a comma 20h. Move a comma 20h. Whatever there in the memory location 20h. Assume this is memory location and it has a data say 33h. Then we have accumulator. Then once this instruction has been executed, this 33h will be copied to accumulator. It will be copied to accumulator. So here we are using directly the address. We are using directly the address in the source. So this type of addressing mode we call it as direct addressing mode. Same, it is not that we can pass, the source can be a direct address. The destination can also be a direct address. Okay, the destination can also be a direct address. Same as it is, we can have the destination as register and the source can be direct address, or destination can be direct address, source can be register. Both destination and source can be a direct address. Both destination and source can be a direct address. These are all the combinations which are possible. That is, first one is move a comma direct address, move rn comma direct address. Rn means where n is from 0 to 7. We can say it as move r0 comma direct address, move r1 comma direct address, like that. Then same as it is, the destination can be a direct address also. Move direct address comma a, where accumulator value will be copied to the memory location. Then move direct address comma rn, that is register value will be copied to the direct address. Then both destination and source can be a direct address. So move direct address comma direct address means between two memory locations the data will be copied. We can go with one example here. Move r1 comma 3ah, that means whatever the data stored in the memory location 3ah is passed to register r1. Here the accumulator data will be copied to the memory location 66h. Then here move 66h comma r2 means the data present in r2 will be copied to 66h memory location. Then the last one, this if we observe, move 66h comma 35h means from the memory location 35h, whatever the data has been present, that will be copied to the memory location 66h. It is between two memory locations is also possible. One thing we have seen in the last one, that is register addressing mode, data transfer between two registers R0 and R1, or that is Rn comma Rn, is not possible. Same implies over here. That is, we cannot transfer with two memory locations, that is 05h comma 03h, where 05 and 03 are R5 and R3. R5 and R3. This instruction remains invalid. We can consider both, so 05 and 03 both are source itself, that is direct address itself. Here it is possible in the above instruction. But when it comes for register, if it is the register memory location, then it remains invalid. Then it remains invalid. This is with the direct addressing mode. And to distinguish between the memory and the address, we can observe it over here. Here we have not used any pound sign or the hash. If hash 20h means it will be data. Without this pound sign, if we are using, then it will be an address. It will be an address. This is with direct addressing mode. Next, we'll see with the register indirect addressing mode. Now, register indirect addressing mode. We are not using the address directly. We are using the address indirectly and with the help of register. That is what this means. We are copying the data from one memory location to another memory location. but the address is not provided directly. The address is not provided directly. The address is provided through the register. Address is provided through the register. We'll see with an example so that we'll easily understand. This instruction, if we consider move a comma at or not, move a comma at or not. So this at indicates the data present in this R0 register should be considered as a pointer. The data present in R0 register should be considered as a pointer or the memory location. It should be considered as a pointer or memory location. We'll consider one example. Say R0 is equal to 33H. That is R0 register is having 33H. Then the memory location of, say, some register, will write it here, 30H, 31, 32, 33, 34. So assume this as a memory location and it has the data something like 00H, 05H, 21H, 62H, FFH, like this. When we execute move a comma at R0, R0 is having 33H, then this 33H will not be acting as a data, it will be acting as a memory location because we are using at symbol. If we are using at symbol before the register name, then this acts as a pointer or the memory location. So it goes to the 33 memory location. Then whatever the data has been there, here we have 62H, that will be copied to the accumulator. That value is going to be copied to the accumulator. Now after executing this instruction, accumulator will not have 33H, it will have the data which is present in this memory location, So this is with the register indirect addressing mode. In register indirect addressing mode, it is not that we can use all the registers R0, R1, R2, R3 and all. We can use only two registers. Those two registers are R0 and R1. We cannot use R2, R3 like that and all. We can use only two registers as a pointer. Now, here in this example, we have taken R0 as the source, that is at R0 as the source. We can interchange it, that is destination can also be a pointer. We'll consider the same. R0 is equal to 33H. Assume accumulator is having 25H value. Now after executing move at R0 comma A, then R0 value remains same, 33H itself. This is after execution. R0 value remains same, 33H. A value also remains same, 25H. Then in the memory location 33H, will have the data 25H. Same we can have move at R1 comma A, that is the destination can also be a pointer. We can also use direct address in the register indirect addressing mode. That means the destination or the source can be a direct address. Or one of the destination source can be a pointer. Here in the example, we have taken 66H as the direct address and at R0 as the pointer. Assume R0 is equal to having same, that 33H. Then the memory locations, 33H is with 20H data and we have 66H where we need to send the data to the 66H memory location from the pointer of the register R0. Now R0 is having 33H, so whatever the data present in this 33H will be transferred to 66H. So 66H will have 20H after this instruction is executed. Once this instruction is executed, then the memory location, the data in the memory location of R0 will be transferred to 66H. Friends, if you are new to this channel and if you like the video, please click on the subscribe button and click on the bell notification to receive the upcoming videos notified on your YouTube app. We'll proceed with next. There is the indexed addressing mode. This indexed addressing mode is used for accessing the code memory. It is used to access the data from the code memory. So to distinguish between whether is it a code memory or the normal RAM structure, we'll be using MOVC instruction. We can observe previously we have been having only MOV instruction. Here we can see it is MOVC, which indicates it is an index addressing mode or we are accessing the code memory. Code memory means it is ROM. It is ROM. So we have only two instructions in MOVC. We'll see that always the destination will be accumulator. We cannot use other than accumulator for the index addressing mode. Remember that always the destination will be an accumulator. Then the source can be accessed as a pointer. The source can be accessed as a pointer, that is we'll be using at. At indicates whatever the data is present in that, it is going to be a memory location. It is going to be a memory location, not the data. Now at here we don't have only one register, we have an operation, an arithmetical operation of addition, a plus dptr, a plus dptr. That means addition of accumulator plus the dptr value will act as the memory location. Will act as memory location. Assume we'll go with one example. So in the example, before executing this instruction, the starting values of accumulator assume as 0, 1H, then dptr is having a value of 0, 0, 25H. Then once this instruction is been executed, MOVC a comma at a plus dptr, first at a plus dptr will be executed. That means 0, 1 plus 0, 0, 2, 5, which will be of 0, 0, 26H. 0, 0, 26H. Now from this memory location, that is from 0, 0, 26H memory location, whatever the data is been stored in this, that will be transferred to accumulator. That will be transferred to the accumulator. If we consider 0026H memory location is having some value 36H, then this 36H value will be sent to accumulator. 36 value will be sent to accumulator. We have one more instruction which is present in index addressing mode, that is MOVC a comma at a plus pc. Destination is should be always accumulator. Then here the source is at a plus pc. Pc means program counter. Pc means program counter. Now we'll go with an example. Assume a register is having 03H, then program counter before at execution of this code, before executing this line of code, assume it is having like 0033H. Now when this instruction is executed, the first step will be program counter will add itself by 1. That means program counter value will change it to 0033H plus 01, which will be of 0034H. 0034H. Next, this arithmetic operation is going to be performed. The second step is A plus PC, which will be of 03 plus 0034. Then we'll get 0037H. 0037H. That means source address will be of 0037H. Then whatever present in 0037H memory location, say assume we have like something like 26H, this value will be transferred to accumulator. This value will be transferred to accumulator. So previously directly A will be added to the DPTR, but when we execute MOVC A comma A plus PC, first step is like program counter will be incremented by 1. Program counter will be incremented by 1. If it is having the value of 0033H, it will change to 0034H. Then later that value of PC will be added to the accumulator value and it will generate a memory location. Here it is of 0037H. From this memory location, whatever the data is present in that memory location will be copied to the accumulator. This is with MOVC A comma at A plus PC. Always this instruction is used to read only ROM data. It is used to read only ROM data. So there are only two instructions for indexed addressing mode. We have only two instructions for indexed addressing mode, and in the destination we cannot use R0, R7, something like that. It is not possible. Or we cannot use any direct address. It is also not possible. Always the destination compulsorily it should be a accumulator. Compulsory it should be a accumulator. Then the source memory location can be generated by at A plus DPTR or at A plus program counter. Friends, this is going to end the today's session. In the upcoming video, we will be going through how to install the Keel software, and we'll go with some examples. Executing these examples, we'll execute it over there, and we'll go on with the next instruction sets. If you like the video, please click on the like button and share it with your friends and the well-wishers. Check out our website www.rlc-EEE.com for the theory content of the videos which we'll be posting in the YouTube. Thanks for watching. We'll see you in the next video.